All right.
Okay, so we first look at scalars. You know what is scalars? Can you tell me what is scalars? Hello?
Uh, yes.
Not definition, exactly what you feel is the right thing. That's it. So basically,
I
when we say
remember
scalar,
scalar.
we simply mean that anything that we simply write a magnitude and a direction. That magnitude, that's it, correct? So suppose you are
Yes.
taking something, you are weighing yourself, correct? And you talk about the mass of
Yeah.
an object. So you say that mass of an object is 2 kg. And it completely describes the mass of the body. You don't need to tell anything else, correct? Same
Right.
way, if you say how much water is there in the glass, so you may say that it has got about 20 milliliter, and you are completely describing the thing, correct? So
Yeah.
any physical quantity, first of all, it has to be a physical quantity. In physical quantity, we simply mean anything that we can be measured, correct? So
Yeah.
physical quantity that simply needs a magnitude. So it simply needs a magnitude. Physical quantity which needs a magnitude, needs magnitude. So when you say magnitude, it has to completely describe it, to completely describe it. Okay. So most of the thing we have studied till 10th were all scalars, correct? Now we come to the actual definition of a vector, and to introduce ourselves we take a example. Okay. So you understood what is scalar?
Yes.
Okay, so this thing which we described over here is a scalar. It's any physical quantity which simply requires the magnitude to quantify it, to tell how much is the quantity of that substance, correct?
Mm.
Okay. Now for a vector quantity, it's not so, as you will see. So let us say that we have a object over here and it is lying on a frictionless surface, because we don't want to introduce too many things, so we say we have a frictionless surface. Now look at this. You apply force in three direction, one direction like this, another direction like this, and you apply another force like this, and let us say that
Mm.
each force is 5 newtons. This is 5 newton, this is
Mm.
5 newton, and this is 5 newton, correct?
Right.
Now you will notice that each factor, the magnitude is the same, each case it is 5 newton, 5 newton, 5 newton, correct?
Yes.
But the force won't be, the quantity won't be same, correct? You'll
Right.
tell me how it will not be same. Well, what will happen if I take only this object? Then it will give the body an acceleration in this direction, or in other words, the body will move in this direction, correct?
Yeah.
Hello? So if I apply only
Yes. Yes.
this 5 Newton force, only the 5 Newton force is acting on this body. So let us say only 5 Newton body is acting on this. What will happen to it? So in that case, what will happen?
Mm.
It will move in this direction, correct?
Right.
So it will move along this direction. On the other hand, if I take the same body, everything is same. The road is same, the body is same, everything over here is same, correct? But only thing is
Mm.
I am applying a force in the opposite direction. This time I am applying a force like this. The quantum of the force still remains the same, it is 5 Newton. What will happen to the body? The body will move in this direction, correct?
Right.
So obviously this 5 Newton is different from this 5 Newton, correct?
Mm.
So how do you specify it? Again we come down and say that any physical quantity, again we have a physical quantity, we have a physical quantity. What does it do? It requires two things. It requires magnitude, as we have seen earlier. In addition, it requires direction. So anything that requires two things to completely specify it, to completely specify it, completely specify it, is called a vector. So it will be called a, is called a vector. Now one of the four example we have seen, force, correct? Another will be velocity. Thirdly, we will have acceleration. Now here you have to be careful about one thing. Merely having magnitude and direction does not make it a vector. Merely having magnitude and vector does not make it a vector. Like for instance, if you look at electric current, correct?
Yeah.
Electric current both has magnitude, correct? It could be 3 amperes and it could go in this direction or it could go in this direction, correct? But it is not a vector. This is not a vector. Because if I say that there is a ampere 3 ampere and there is 5 ampere, you simply literally add them as if they are numbers, correct? So it will become 8 amperes. On the other hand, if a 3 ampere is going this way and a 5 ampere is going other way around, we simply
You can't
subtract
add
and
it.
2 ampere, correct? Okay.
Yeah.
So there is no direction involved in it, either its addition or subtraction, or in other words, this quantity does not use vector addition, correct?
Yeah.
So
Yeah.
not only should it have magnitude and direction, but it should follow all vector laws, okay, which we will see later on, all vector laws. So did you understand these two parts?
Yes.
Another thing which is very important to notice is pressure. Again, pressure is actually written as force upon area. Now force is
Area.
a thing, but it is not a vector because its direction is always perpendicular to the surface. Okay,
Right.
so it doesn't have any other specific purpose. We can't resolve the pressure, so it's a scalar quantity. Again, when you add it, it is simply added as a scalar, correct? So is
Right.
this all thing clear to you now?
Yes.
Okay. Now we go and see how do you really use the vector. So first of all, we have to understand how do you represent a vector. Okay. So how do you represent a vector? Represent a vector. Now, first of all, remember you can represent it schematically. Schematically means in the form of a diagram. So suppose there is an object over here and you have suspended it with a string and you are trying to pull it this way. So you can say that this is your tension and this is your force. Or there is a vehicle over here and you are trying to pull it this way and you are also trying to push it this way. So there is a pull of 3 Newton and there is a push of 6 Newton. Or most importantly, there is an object lying on the floor and you've got a small hook, you're using 2 threads to pull it upwards. This is exerting a force of 3 Newton and this is exerting a force of 4 Newton, correct? Alright. So all these are ways of writing schematically, in which a vector is written as a arrow. The arrowhead shows the direction and the length of the arrow, correct? The length of the segment OL is proportional to the magnitude. Is proportional, not equal, okay? And the arrow gives you the direction. So this is a schematic way of writing it. Second thing is, how do you write it symbolically? So you want to say that you are going to add two vectors. So either you write it as AB, or you could write it as PQ. Sometimes you may use a single letter A to use it. Again, when you enclose it between two parallel lines, what happens? You denote its magnitude. So this denotes the magnitude. So when I say P and Q and I put between two lines, it's a magnitude. If I write it A
Yeah.
bar and this is the magnitude, this is the actual vector, this is the magnitude, correct?
Magnitude.
Then
Yes.
again, if I want to write a unit vector, then I can write it like this. So if I want to write unit vector PQ, it is like this. If I want to say unit vector A, this way. So a vector can be written as actual sense, its magnitude, and unit vector in its direction, which simply gives you the direction. Okay. Is this clear? Okay.
Yes.
Furthermore, we can write it mathematically. Now that is important for us because that's what we are going to do throughout our physics class. So mathematically, we write it in terms of unit vectors I, j and k. Okay, these are all unit vectors. So if you say 3i plus 4j plus 6k, then this is vector A bar. Okay.
Yeah.
Again, if you want to find the magnitude of this A bar, what you do, you square
Use
the
the 3
multiple.
square
So
plus
here
4
it will be
square plus 6
9
square.
plus 16 plus 36.
36.
Correct. Again, you want to find the unit vector, you take the vector A bar divided by its own magnitude, you get unit vector. Correct. So you can use three ways: schematic, symbolic, and mathematical. Is this clear?
Yes.
Okay. Now once we have figured out the vectors, let us look at type of vectors. Correct. So let us say that we have got two vectors over here. Now look at this, we got two vectors here like this. One thing you notice is they are parallel to each other. So let us say that one
Yes.
vector is AB, the other vector is PQ. Okay. Also, the length of the segment AB is equal to length of PQ. Then obviously what you will say that the vector AB should be equal to the vector PQ. Correct. On the
Yes.
other hand, you have the same vector, you have another vector over here like this. Now this is MN. Also remember that the length of MN is equal to length of AB. But as you can see, they are in opposite direction, correct? So
Yes.
you can say that the vector Mn will be negative of AB.
Negative of AB.
AB. Now let us say that we have an object over here, like in the previous case, and let us say that we have a force of, let us say, 6 Newton acting in this direction. Let us say we have another force which is acting like this, and its magnitude is also 6 Newton. So what will happen to the object? It will not go
It will
anywhere,
not move.
correct? So you will
Yes.
get what is called as a null vector. So now you get what is called as a null vector. Now remember, for null vector, what happens in a null vector? Its magnitude is 0. Magnitude is 0,
0.
but its direction is undefined. Its direction is undefined.
Undefined.
Direction is undefined. You cannot say anything about the direction, correct? Okay. So
Meaning it can be either direction, right?
it doesn't have a direction per se. That's why we say undefined. We don't know about the direction at all. Okay. So
Okay.
mathematically it means
Okay.
that we don't know anything about it. Correct. Okay. That's why we don't say zero vector. We call it null vector. Okay.
Hmm.
Remember the word terminology null. Equal is when they have same magnitude, same direction. Opposite is when they are same but opposite direction. Zero vector is when they have no magnitude, and sorry, magnitude is 0, direction is unknown. Okay. Is this thing clear,
Hmm.
understood by you?
Yes.
Okay. Now one very important thing is, many a times we use a vector only to show where a object lies. So let us say that we draw our coordinate system, we draw it like this. We have one coordinate system, the x like this, we got y like this, and we take z this way. So let us say that we take z this way. Okay. Okay. And we call this vector as, this is your x axis, this is your y axis, and this is your z axis. So let us say we have got a point P here. Just for sake of convenience, let us give it a coordinate x, comma y, comma z. It has three coordinates because we have got three axes, correct?
Hmm.
And O happens to be the origin. Of course, its coordinate will be 0, comma 0, comma 0. Now what you do is you draw a vector from the origin to this point, correct?
Hmm.
Then
Yeah.
this vector OP that you have just now drawn is called the position vector. It's called the
Position vector.
position vector of point P. Okay. Now that is very important for you. Did you understand position vector?
Yes.
Okay, that is the vector which is used to describe a position. Remember, for a position vector, it is very important that you have a coordinate system, correct? So
Hmm.
it has only relevance if there is a coordinate system. Now, if you are looking at it on the plane, So let us say that we have got a plane and all our points are lying on the plane. So we have got one axis like this, we have got another axis like this, we have got only two axes. Correct. So we have a x axis here, we have a y axis here, and we have a point q here. It will have only two coordinates x, y. And you take a vector and join it from the origin to this point, it will be the position vector of q. Okay.
Mm.
So this point vector OQ, it will be the position vector of q. So is the position vector of q. Okay. Is this clear?
Mm.
Okay.
Yes.
Now same way, if you have only one dimension, that is we are talking about body moving in only one direction like this, correct? And let us say that here in our case the origin happens to be here. This is our origin, let us say. So we call this as O. And we have got 2 points over here. We have a point P here and we have a point Q here. Correct?
Mm.
Now we talk about the vector here, that is OP. Same way we talk about the vector OQ. So let us say that the distance over here is 4 units and this is 3 units. Correct? So OP will be the position vector of P. OQ will be the position vector of Q. Correct? And remember, OQ will be negative because it's in the opposite direction. Okay. So
Mm.
position vector could be in 3 dimension, 2 dimension, 1 dimension. Correct? But nonetheless, it is a position vector, so everything about the position will be the same. Correct? Okay. Okay.
Mm.
Now we go to another important aspect of what we have to learn, and that is called unit vector. So unit vector. Now as the name suggests, what will be the magnitude of unit vector? It will be unit, so it will be 1, correct?
1.
But then unit vector has to be specified in a given direction, correct? So we define
Mm.
unit vector as a vector of magnitude 1, of magnitude 1, or unity, you can call it as unity, in a
Mm.
specific direction, in a specific direction. So let's take an example of our coordinate system again, and let us say that we describe, this is our y-axis and let this be our x-axis, and let us say that we have a z-axis like this over here. So we have our y-axis, or we can say this is our z-axis, this is y and this is x. So let us say that our unit vector is along the x-axis. So this is a unit vector along the x-axis. Let us give it a name I. So I is a unit vector along the x-axis, and let us say that j will be a unit vector along the y-axis and k will be a unit vector along the z-axis. So what is this? This is j vector and this is k vector, correct? So if I want to say that I have gone along the x-axis 3 units, so if I write 3i, what does it mean? That means I have gone 1, 2, 3. That means I am here, correct? Okay. Hello. What is
Yeah.
I? I
Yes,
is
sir.
a unit vector along the x-axis. Same way, if I describe a vector 1 unit, 2 unit, 3 unit and 4 unit, it will mean minus 4j, correct?
Minus 4j.
And if I take something like this, 1 and then 2, so this will be minus 2k.
Minus
Understood?
2k.
Remember, for a unit vector, we always have the cap. So did you understand ijk?
Yes.
Okay. So now that we know unit vector, its magnitude is going to be 1, but the direction, in every direction we will have one specific unit vector. So suppose that we have a vector AB, and let us say our vector is this way. So it is A here and it is B here. So if I take
Mm.
the same vector AB, divide by its magnitude AB, then its magnitude will become 1, correct?
Mm.
Okay. and it will be in this direction. Is this clear? And this particular vector that we just arrived at will be written as AB with a cap, that means unit vector. So the concept of a unit vector is clear to you?
Yes.
Okay. Now with this help, we will go ahead and see some more things. Okay. Now we'll ultimately look at the position vector in terms of coordinates. So let us say that before that, let us try what happens when you want to add a vector, correct? So we will look at operations on vector. Okay. So first, let us say that we have a horizontal surface and we have kept an object over here. To begin with, I apply a force of 6 Newton on this side, apply a force of 4 Newton on this side. So let me specify that. So I have applied a force of 6 Newton this side and 4 Newton on this side. What will be the total force?
10.
10 Newtons towards the going towards the right, correct?
Right hand side.
Good.
Yes.
Now, if I do the other way around, I keep this force as it is, but then now I apply a force of, this is a force of 12 newtons. A force of 12 Newton
Hmm.
is acting on this side. Force of 6
Hmm.
Newton is acting on this side. What will be the net force? It will be 6
6
Newtons acting
Newton left
towards it.
hand side.
Correct. In
Left hand side.
convention, we will take anything going this side is positive, anything going this side as negative, anything going up is
Hmm.
positive, anything going is down in 9 downward. So this will become 9. But here, if you notice, everything was along the same line, correct?
Right.
So now let us look at something which is very important for us, and that would be, if you take an object, let us say you have a vector over here, and let's call it as OP. So this is a vector O here and it ends at P here. Now you have got another vector which starts here and ends over here, let us say. And let's name this as OQ. Now how do you find the resultant? We know the angle between them as theta. Correct? To find the resultant, what we do is, we draw a line parallel to the earlier vector starting from Q. We again draw a line parallel in this direction, okay? And
Hmm.
let us see where it meets. So let us say that it meets at R. Then we join the vertex of the, we join the point where the two vectors were meeting to the point where they meet again, correct?
Hmm.
So now what happens to OR? The vector OR is called the resultant of OPU and OQ. You don't say addition. It is resultant of OP and OQ. So
Okay.
simply you write it as OR is equal to OP plus OQ. Now remember they are vectors, and this law is called law of addition of parallelogram law of addition, correct? So we write it as law of, wait, parallelogram law of vector addition. Okay, is this clear? Okay,
Yes.
good. Now let us say that instead of this configuration, our original vector OP was here only. That is correct. It was over here. This vector was here. Okay. But our OQ was this side. OQ was here.
Hmm.
So again we write this as OP. O I have to write. And then I have got OQ. Now what is the resultant? Well, the resultant would remain the same. It would go from here to this point. And that will become again OR. It's just a matter where the Q was. OQ was this side, that means both had the same end. In this case, the beginning of one was the ending of the other, correct? So this is called parallelogram. This is called triangular addition. Okay, is this clear? Now in terms of the magnitude, suppose we say that this vector was P, this vector was Q, and let us say that this vector was R. Then remember that magnitude of R, correct, is given by magnitude of P the whole square plus magnitude of Q the whole square plus 2 times the magnitude of P into magnitude of Q into cos theta, and this is square of this, correct? Remember, here we are talking about the magnitude only and not the direction, correct? Hello? Now,
Yes, yes.
the direction is given by the angle it makes with the vector OP. So in that case, your tan alpha is given as magnitude Q sin theta divided by P plus Q cos theta. So now you know the direction, you know the magnitude, so you know the resultant R, correct? Now this particular number which we are doing, it is true for both parallelogram and triangular law. It won't make much of a difference, okay? Only difference would be the angle theta would be here and the angle alpha would be here, okay? Is this clear? Hello?
Yes,
Did you
yes,
get
yes,
this thing correctly?
yes.
Okay. Now try and tell me, suppose the magnitude of my P is 4. The magnitude of Q in our case is 3. And the angle between them is, let us say, 90 degree. So what should be R and what should be alpha? You got the formula right in front of you. You can
Yes.
use and tell me the answer.
R is 5.
R is
5.
5. Okay. That is good. What about, this is 5. What about the alpha?
Yes. 1 second.
So you can write it as tan inverse, correct? 3 upon 4.
Hmm.
Okay.
Yes.
Now
0
this
point
part is important. 3 upon 4. Okay.
5.
This would be actually 53 degrees. Not
Yes.
53, sorry, 37 degrees. Okay. Is this clear?
Hmm.
Fine. Now let's try something a little different. Okay. So let's try an occasion in which I remove this part. Okay. Now in our case, P is given as 10, Q is also 10, correct? R
Hmm.
is also 10, correct? Can you tell me theta?
Yeah.
Remember, all of them are same. I am asking you theta.
Hmm.
And once you get theta, please also tell me what is the value of alpha.
Hmm. getting negative.
No, it doesn't matter.
Theta's
What is cos?
theta's
You tell me
cos
first of
inverse
all, what
of
is cos theta?
-1/200.
Minus 1 by 2, not 200.
Hmm.
Check it out.
Okay. Yeah, yeah, yeah.
Minus.
Yes, yes, yes.
So that
Yeah,
means your
yeah, I've
theta will be
got it.
120. Your theta will be
Yes,
120, correct?
120.
Now tell me what is
Yes,
alpha? Formula is right in front of you.
yes,
And now you also know theta, correct? So you have to find out alpha.
yes.
By the way, sine 120 will be root 3 by 2 and cos 120 will be minus 1 by 2.
5 √3, √3. Tan alpha will be √3.
Okay, fine. Tan alpha will be root 3, so alpha should be 60, correct?
Yes,
Okay, fine. Having done this, now I'll ask you one more question, a very simple one in that. Suppose I say that this is my vector OP and this is my vector OQ. So let me put the words over here. So you are very specific of what we are talking about. This is vector OP and this is Q. I want you to tell me OP minus OQ or PQ. OP minus PQ. OP vector minus PQ vector. So look at this, what you do is rather than doing it manually, what we do is we write minus OQ. So minus OQ will be something like this, correct?
yeah,
It will have the same magnitude but it will be in the opposite direction, correct?
yeah.
So this particular vector over here will be minus PQ, minus PQ.
PQ.
And we actually want OP plus minus PQ, correct?
Yeah.
So actually what we'll have to do? Well, we'll have to write parallel line like this. We'll have to write another parallel this way. And this what you get will be OP minus PQ. Is it clear?
Yeah.
Hello?
Yes.
Okay. Now having said this, let us see something else. Let us also try a little bit more about the negative aspect. So let us say that you have got a vector here. Let's call it as AB. This is A and this is B. And then you take another vector. Let's call this as C. We know what is AB plus BC, correct? But now we want to find out what is vector BC minus vector AB. So what you should reverse the direction? We should reverse the direction of which vector, BC or AB?
A, AB.
AB, correct. So that means to say we simply have to draw the same vector that was originally
Opposite
there,
direction.
opposite direction. So it will be like this, correct?
Mm.
Okay. Now if you apply the vector parallelogram vector, you will have one vector which will be like this,
Mm.
correct? And then we will have another vector which will be like this, correct?
Mm.
Parallel, so it will be like this. So we will get a vector how? Now this is BC and AB, so our actual resultant vector will look like this, correct? The resultant
Mm.
vector should be like this, correct? Isn't it?
Right.
So this
Yes.
vector that we get will be equal to AB minus BC, correct? Okay. So
Minus
this would be
PQ.
what? This will be equal to AB correct,
minus
sorry,
BC.
BC minus AB. Okay,
Hmm.
is this clear? Okay, now let's go ahead and see, which is we are going to use something very practical. Let us say that a person is going on a road in this direction. So let us say that this is the velocity of a man, correct? So let us say this is velocity of man, and let us say at that point of time rain is falling like this. So, oh sorry, we want to show that the rain is falling vertically downward. So rain is
Hmm.
falling like this. So let us say that this is the velocity of rain. We want to
Hmm.
know the velocity of the rain with respect to the man. That means how does a man see the rain? Okay. Now
Hmm.
we will see this later on much when we do relative motion, but at the present moment I'll write a formula for you. It is velocity of the rain minus velocity of the man. Now remember, all of them are velocity here. Huh?
Vector.
So now who are we trying to take it negative? We are taking negative m,
Velocity of man.
velocity of man.
Yes.
So we will redraw his thing and we will say that no, he is going this way now. Okay.
Hmm.
Now this fellow is coming down and then going this way. So the resultant velocity will be this one, correct? Okay.
Hmm.
Hello. So this will be
Yes,
what?
yes.
This will be the relative velocity of rain with respect to the man. We all know that we
Man.
hold our umbrella like this. So if you are really going and we have an umbrella, we'll hold the umbrella like this, correct?
Hmm.
Okay, and that is how you do the negative part. So did you understand how to add them, how to subtract them, correct?
Yes.
Okay. Now in addition to this triangular and vector law, we can also have a lot of other laws. Let us say that you go from here to here, and then you go from here to here, then we go from here to here, then we go back this side, and then we vertically come down, correct? You come this way.
Hmm.
So just to put the name on it, you were at, originally you started at O, you went to A, you went to B, you went to C, you went to D, and ultimately you got tired, you stopped at E. So the resultant would be this vector, correct? The
Hmm.
resultant would be this vector, correct? Okay. Now what are you doing? Here you are writing parallelogram of vector addition. So OE would be equal to what? It would be equal to OA plus AB plus BC plus CD plus DE. Is this clear? Hello? Did you
Yes.
understand this? And this is called polygonal law of vector addition.
Hmm.
Vector addition. So when you physically subtract, you simply make one of them negative and then add them, you get the negative subtraction of the vector, correct? Okay.
Hmm.
Well, now let's get back to what originally we decided about writing the vector as aijk, correct?
Hmm.
Did you follow everything that I told you now?
Yes.
Any difficulty in this part?
I had one question in the previous part
Tell
which
me.
you taught.
Tell me what?
So when we were talking about the rain and the man,
Hmm.
could we have used the the parallelogram law instead of the triangle one?
You can do anything, na? But the thing is, the
Either you can use.
ah, correct. In fact, we
Okay.
use the triangular, but parallelogram उसको ये बाजू लेके आ जाओ, आ गया आपका vector, correct? बराबर है?
Yeah.
देखो, for instance,
Ha ha.
what we had done over there was we had done one vector like this, and then we had taken our Mr. Rain coming down, correct?
Hmm.
So we said that let the rain be. We have taken this negative, correct? इस ऐसा ले लिया और इस बंदे को ऐसा ले लिया, correct?
Hmm.
बराबर है. तो यहाँ पर आप पैरेललोग्राम क्यों नहीं ले सकते हो? बिकॉज यू स्टार्ट फ्रॉम ओ एंड समवेयर एंड द अदर बिगिंस फ्रॉम द सेम प्लेस, करेक्ट?
Hmm.
Okay. Now suppose instead of that I had drawn the thing a little differently. Suppose I had taken that this is the negative direction of the man and this is the direction of the rain. Correct?
Hmm.
Then I would have used
Yes.
parallelogram law. Correct?
Hmm.
But nonetheless, look at this. The direction is the same only, no?
Yes.
See, this direction of this particular vector, correct direction of this particular vector, and the direction of this vector is same. Even the magnitude will be same. Correct?
Yes.
Did you understand? Both are
Hmm.
equivalent. We lose whichever is convenient to us. Is this clear?
Hmm.
Have I made
Yes.
myself very clear? Any
Yes.
doubt?
No.
Okay. Now let's look at the bigger picture. So let us again go and say that this is our y axis and this is going to be our x axis, and let us say that this is going to be our z axis. So let's name them. So this is our x axis, this is our y axis, and this is our z axis. And our point over here is at the top somewhere over here. This is x, y, and z. Now, if I put the drop the p on the xy plane, then this will become p dash, and I can write it will have x coordinate and y coordinate same, but its z coordinate will be 0. Correct? Hello.
Hmm. Yes.
Now I draw perpendicular lines from this P to the y axis and to the x axis, and there I
Hmm.
name them as this is M and this is N, and this of course is O. Okay. Now this will be equal to x I cap, this will be equal to y j cap. Correct? So what will be
Hmm.
O P dash equal to? So O P dash, this particular thing,
Hmm.
what will it become
Z.
equal to?
Oh. Z.
So
C
O
cap.
P dash, no, O P dash according to parallelogram vector will be equal to O M plus O N. Am I
Plus
right?
O N. Yeah, yeah,
So
yeah.
it will be equal to
X I
X
cap
I
plus
cap, correct, plus
Y J cap.
Y j cap, correct.
Hmm.
Now look at this.
Yes.
If I join the vector OP to P dash, P here, this part, correct. Then I can also
Hmm.
write this as my actual position vector OP will be equal to OP dash vector plus P dash P vector, correct? Hello.
Hmm.
See this
Hmm.
vector plus this vector, correct?
Hmm.
So now I can write this as X I cap plus Y j cap plus Z k cap, correct? Is this clear?
Hmm.
So that is how you come across the mathematical notation of any vector, correct? So it means the distance traveled along the x axis plus distance along the y axis plus distance traveled along the z axis will give you the actual position where you end up, correct? Hello,
Hmm.
is this clear?
Yes. Hmm.
So can we go ahead?
Hmm. Yes.
Good. So now let's say further, let's pick up something else over here as we go along, and let us say that, okay, so let's start and say that we have got two vectors. One vector is here, one position vector here, and another vector is here. So let's say that this was O, and this is a point A, which is x1, comma y1, comma z1. This is a position B, and its coordinates is given by x2, y2, z2. Tell me what is the position vector of OA? How will you write OA? You will write it
Position
as x1 I
X
cap,
I cap plus Y1 J cap
y1
plus
j
Z1
cap,
K
correct,
cap.
z1 k cap. Similarly, how will you write OB?
X2 I cap plus Y2 J cap
Good.
plus
x2 I
Z2 K
cap
cap.
plus
Y2
y2
J
j
cap.
cap plus z2 k cap.
K cap.
Now what you do is just join this vector AB.
Hmm.
Now they say remember it is BA. So I want you to tell me what is vector BA. So see, if you write carefully, look at it, it is OB,
plus
correct?
OA.
Plus BA will be equal to OA, correct? Hello.
Hmm.
So I can say that my vector BA will be equal to OA minus OB, correct?
Hmm.
So I can write this as x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap, correct? Hello.
Hmm.
Is this clear? And of course, if I am asked what is AB, you know what will be AB equal to? OB, the lateral point, minus OA. Understood? So in this case, it will become what? It will become x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Is this clear? Hello.
Yeah.
So let us say that in practice you are given a point P which is given as 3 comma 4 comma 2, and then you are given a point Q as 1 comma 2 comma 5. First of all, you tell me what is OP as a vector, tell me what is OQ as a vector, and then tell me what is PQ as a vector. Please work this out. Yeah, you got OP vector.
No, just a minute. QP is 2I cap plus 2J cap minus 3K cap.
So this will be equal to 3 I cap plus 4 j cap plus 2 k cap. Am I right?
Hmm.
And this will be equal to, this will be equal to
I
I
cap
cap
plus 2J cap
plus 2 j cap plus 5
plus
k cap.
5K cap.
And when I write
Hmm.
PQ, it will be OQ minus OP. Am I right?
Hmm.
So this should be equal to minus 3I, correct? Minus 2I.
Hmm.
And this will
Minus
be
2I,
minus 2J
2J
plus
plus
3K.
3K.
Achha. Now we talk about what is the magnitude of PQ. Magnitude of PQ is very simple. You square each of the term.
Root of 4,
Square of 2 will be
4 plus
4
4
plus 4
plus
plus
4
9.
plus 9.
So it will become how much? 17, root
Root
17.
17.
Now tell me what is the unit vector in the direction of PQ? Unit vector in the
Uh,
direction will turn out to be minus
PQ
2
vector.
I cap
Okay.
minus 2 j cap
Yes.
plus 3 k
Plus
cap
3K cap
divided by
upon
root
root 17.
17. Okay, is this clear
Yes.
now? Okay.
Yes.
Okay, before we go to the next topic, let us do one more example. Now here you are given the point A as equal to minus 1, minus 3 and 4. You are given the point as B equal to 4 minus 6 and 2. You have to first find out the vector OA. You have to find out the vector OB. Then you have to find out the vector BA. Then you have to find out magnitude of BA. And then of course you have to find out the unit vector in the direction of BA. Will you be able to handle this? Go ahead and finish it off.
Done.
Yeah, tell me OA
Minus I cap
minus
minus
I
3j cap
minus 3 j cap. Okay,
plus 4k cap.
4 k cap. Good. What about this?
OB is 4I cap minus 6j cap plus 2k cap.
Then this is equal to how much?
BA minus 5I cap
5
plus
a cap
3j cap,
plus
3j cap
okay, 3 j cap. Fine.
plus 2k cap.
What about the magnitude root under?
Magnitude is root 38. Root 38
25 plus 9 plus 4. How much
plus
root?
4.
Root?
38. 38, I think.
So
Yes.
unit vector will be minus 5i
Plus
plus
3j
3j plus
plus
2k
2k
divided
by
by
root 38.
root 38.
Root
Okay, so
38.
you understood this part. Correct. Let's go to next one.
Yes.
Now in the next part we look at product. So suppose you are already given a vector. Okay, just a second. So let's say that you already have a vector. Let us say we have a vector a bar is given as 3 I cap plus 4 j cap plus 2 k cap, and you want to do 2 times a. So simply
Hmm.
meaning 2 multiplied to each one of them. So it will be equal to
6i cap
6 I
plus
cap
8j cap
plus 8 j cap
plus 4k
plus
cap.
4 k cap. This is called a scalar multiple of a vector quantity. So this is actually not actual multiplication. It's a
Hmm.
scalar multiple
Scalar multiple.
of a vector quantity. Fine. Now we look at the vector multiplication. There's nothing called as vector multiplication per se. But suppose we have a
Hmm.
vector, let us say A bar. And let's say that it is given
Hmm.
by component wise AX with the I cap plus AY with the J cap plus AZ with the K cap. And there is
Hmm.
a vector B bar which is given by, of course, its components BX I cap, BY j cap plus bz k cap. Now we look at a very different quantity. We call it as A and B coming together, and both of them come together, and what do they give? They give you a scalar quantity. Remember, both of them were vector quantity. When they came together, what do they give you? They give you a scalar
Scalar.
quantity. So you have force, which is a vector, displacement, which is a vector. When they come together, they give you work. So this
Work.
is an example of what we call it as scalar product.
Scalar quantity.
Scalar product. So this way,
Correct.
when something happens, the interaction between two vectors produces a scalar quantity. We call it scalar product, which is synonymous with the word dot product.
Hmm.
So what we are actually doing in dot product is simply writing a dot, correct? But what
Hmm.
does it A dot B mean? It means magnitude of A multiplied by magnitude of B and multiplied by cos theta. Now what the hell
Cos
is
theta.
theta? Theta is angle between the vector A bar and the vector B bar. Okay.
B bar.
Is this clear? Okay.
Yes.
So whether you write A bar dot B bar or you write it as B bar dot A bar, no, doesn't make a difference. They are number, correct?
Hmm.
Additionally, most importantly, if A bar is not equal to 0, B
Hmm.
bar is a non-zero vector and A bar is perpendicular to B bar, then what is the
Hmm.
value of theta? Theta is 90 degree, correct?
90
So
degree.
what will
Yes.
happen to cos theta? That will become 0, correct?
0.
So
Yes.
obviously A bar dot B bar will be 0. This is a
Hmm.
very important condition to find out whether the vectors are perpendicular, correct?
Hmm.
Additionally, if I take a vector A bar and take a dot product with itself, so according to this rule, it should be mod of
Hmm.
A into mod of A into cos 0. Now remember, cos 0 is 1, so it will become
1.
mod of A the whole square. Now this is also a very
Square.
important thing that we will use in our arithmetic. Okay,
Yes.
is this clear?
Yes.
And if you take I cap, multiply with I cap, you will get 1. If you take j
Hmm.
cap, multiply by j cap, you will get 1. You will get k cap, multiply by k cap, you will get 1. But if you take I cap multiplied with j cap, you will get 0. If you
0.
take k cap multiply with I cap, it will be 0. You take j cap multiply with k cap, it will be 0, correct?
Hmm.
Okay. Now this gives rise to a very important thing for us, that A bar dot B bar will simply be equal to the component wise multiplication AX BX plus AY BY plus AZ BZ, correct?
Hmm.
Hello? Is this clear?
Yes.
So all that you need to do is simply multiply these two,
Hmm.
multiply these two, multiply these two and add them, correct?
Yes.
And also, if you use this rule which I have written here, you can also find out that cos theta would be equal to A dot B into magnitude of A, which we have done now, how to calculate, and magnitude of B, correct?
Hmm.
Is this clear?
Yes.
Did you understand this part very clearly?
Yes.
Good. Can we go ahead?
Yes.
Good. Now, let us say that I have given you an example here. I have given you A bar is equal to 3 I cap plus j cap minus 2 k cap. B bar is equal to minus I cap plus 4 j cap minus 3 k cap. Find
Hmm.
out what is A bar dot B bar. Find out what is mod of A, what is mod of B, and tell me what is cos theta. Of course, cos theta will be equal to what? A bar dot B bar upon mod of A into mod of B. Okay, sure. Finish it off. What was AX into
First
BX?
one
You
is
remember the formulas?
7. Yes.
So this will be equal to minus 3 plus 4 minus 6, correct? Hello?
Plus 6, right?
Plus 6, sorry. Yeah. So it will become how much? 7.
7.
Now mod of A will be
Yes.
how much? It will be 9 plus
Uh,
1
9
plus
plus
4
1 plus
plus
4.
4 and root of that will be root 14.
Yes.
What about B bar? 1
1 plus
plus
16 plus 9.
16 plus 9 root of
Root
26.
26.
Correct. So your
Yes.
cos theta will be equal to 7 upon
7 by
root 14
15
root
into root
26.
26.
Correct. So did you understand this dot product? Correct.
Yes. Yes.
Additionally, let us look at this, that suppose you have already got a vector here. Let's call this vector as A bar.
Hmm.
And let's take another vector here and let's call this vector as B bar.
Hmm.
And let's say that we want to draw the shadow of this vector here. That means we want this part. Okay.
Hmm.
This is called projection of A on B. This is projection of A
A on
bar
B.
on B bar. Okay. Which is actually equal to A bar dot B bar. Okay. Into magnitude of B bar into unit vector in the direction of B bar. Okay.
Hmm.
Same way, if I ask you projection of B bar on A bar, it will be A bar dot B bar as it is. Only thing is this thing will change. Correct?
Hmm.
Mind you, these two are unit vectors. Huh?
Yes.
So it's just a question of computing. Correct? Okay. Is
Hmm.
this clear?
Yes.
Good. So let's take an example first of all. Let's say that our A bar is equal to I cap plus J cap minus K cap. Let's say B bar is equal to 2 I cap minus J cap plus 3 K cap. Tell me projection of B bar on A bar.
One. Minus 2 by root 3 into 8 cap.
Got the answer? Hello?
Uh, yes.
What is it?
Minus 2 by root 3 into A cap, right?
Hmm.
And A
See,
cap will be
basically
A
this will
bar.
be a number. So first you tell me what is AB, A dot B. It will be 2 minus 1 minus 3, correct? So
Yes.
it will be
Minus
minus
2.
minus 2, correct? So this
Yes.
one is minus 2, correct?
Yes.
Now unit vector in the direction of A, correct? That will be
Hmm.
root 3, okay?
Yes. Root 3.
And then this number has to be multiplied by unit vector in the direction of B. So it will be
Hmm.
equal to 2I minus J plus 3K multiplied by its magnitude. Sorry, it's A, huh? I made a mistake. It should be multiplied by unit vector in the direction of A,
A.
correct?
Yes.
So unit vector in the direction of A will be what? It will be 1
I
this
cap plus
divided by
theta.
root 3, correct? Hello?
Yes. Yes.
Good. So now we look at something very important. This was all mathematical. Let's get down to something physical. So let us say that we have a inclined plane. And let's say that we have a body over here like this. Let us say that this angle is theta. We
Mm,
know that the weight of the body will always be vertical, correct?
mm,
It will neither go down, correct? Because the wedge will stop it from going down. So you can break this W into two parts, one like this and one like this. If this angle is theta, this will also be theta. We write this W as W cos theta and write this
mm.
as W sin
Sin
theta.
theta.
So the force with which it goes down will be W sin theta, correct?
Mm,
The idea of breaking it into cos theta and sin theta is wherever the angle is there, that side it will become cos theta and the opposite will become sin theta. Okay, is this
mm,
clear? So let us say that on a plain road like this, we are trying to carry our bag, other heavy one over here, and we are applying a force this way. And this force over here, we have got two components, horizontal and vertical. And we are given this angle as theta. And this is our force F. Then we will write this as F cos theta. We will write this as F sin theta. Okay. Is this clear? Let's also take another example. We have a rigid support, and from that support we have suspended an object with the help of a thread like this. At present, what is happening? The weight of the body is acting downward, and the string is counterbalancing it with its own force. So in this case, what is happening? The weight of the body is nicely balanced by the tension in the string, correct?
mm,
But if I change this to this position here, then things goes a little different, correct? So if I take the mass this side, now weight will never change, weight will be the same, it will be down like this, correct? Okay. So weight is not going to change, weight remains the same. This angle over here is theta. Now I have got tension in the string. So I have got two components of it. One is weight like this and one is like this. So this will be equal to W cos theta and this will be equal to W sin theta. Is this clear? Hello. Did you
Yes.
understand resolving of forces?
Mm,
So this is called, is this clear?
mm,
And it's a very simple way of understanding it. So let us say that we take a rectangular block, let us say, and let us say that our force actually is acting from here to this point, and we are given one angle, any angle over here, and this vector, let us call it as a bar. So this would be a cos theta and this would be a sin theta. Now according to parallelogram addition, a square cos square theta plus a square sin square theta will be equal to a square, because cos square theta plus sin square theta is 1, correct? Hello.
yes.
That is how we get this resolution of vectors. Is this clear?
It's 2a square, right?
No, no.
Oh,
Your a
no,
square will
sorry,
come.
sorry.
A square
Yeah,
will get
become
come.
common, right,
Okay.
right. Sorry.
Is this
Yeah,
clear?
yeah,
Okay.
yeah.
Good. So fine. Now we go to do what is called as vector product. Okay. So what will happen in vector product? Well, there is nothing great. You will have a vector a bar and you will have a vector b bar. Together, when they come, they give rise to another vector, which we write it as a bar cross b bar, cross simply because it should look different. But remember, this is not a scalar, it is a vector quantity. And therefore, this interaction is called a vector product. So here it will have magnitude a bar cross b bar, which will be equal to magnitude of a bar into magnitude of b bar into sine theta, which shows that if a bar is parallel to b bar, then what will happen? A bar cross b bar will become 0. Okay. And its direction is given by, its direction of the new vector is given by what we call it as a right hand thumb rule. Is this clear? This gives the magnitude of the new vector that we have got, and this gives its direction. Okay. Is this clear? Hello.
Yes.
Also remember, if I were to write this as J, I and K, J cross I will give me K, I cross K will give me J, and
Yeah.
J cross I will give me I. If I go
I.
the reverse way, it will become negative. Correct?
Okay.
So
Okay.
let me say that my A is written as AX I cap plus AY J cap plus AZ K cap, and B is given as BX I cap plus V by J cap plus BZ K cap. Then actually to get the vector A bar cross B bar, I have to use something called as determinant. First I write I write J, I write K. Then what is the first vector A? So I'll write its component AX, AY, AZ, BX, BY, BZ. Is this clear? Hello.
Yes.
In addition, look at this. Suppose you have already have a vector. Suppose there is a triangle. This is a vector A bar. This is a vector B bar. So this is A bar and this is B bar. Let me say that I finish this triangle. And now I name this triangle as OAB. So area of triangle OAB will be equal to magnitude of A bar cross B bar divided by 2. Okay, is this clear?
Yes.
So it will be equal to magnitude of A bar cross B bar equal to 2. Okay, is
Mm.
this clear? Hello.
Yes.
And of course, if
Yes.
this is
Yes.
a parallelogram, then it will be simply equal to, suppose I write it as C. So area of parallelogram OACB will simply be equal to A bar cross B bar. Okay. Hello.
Yes.
Good. Can I go ahead?
Yes.
Good. Now let us say that I have given you this A as equal to I minus J, and B bar is equal to minus 2J plus 3K. How do you find out A bar cross B bar? Then how do you find the magnitude of A bar cross B bar? and then you find unit vector in the direction of A bar cross B bar. So obviously you'll write this as I, you'll write this as J, and you'll write this as K. 1 minus 1 0, 0 minus 2
minus
3,
2, 3.
and then of course you have to write plus minus plus. So I will be multiplied to the square over here, so I'll get minus 3, correct?
Minus 3.
Then I have got minus J, and then I have to multiply by 3,
3.
minus 0.
Yes.
And then I'll have to write plus K, and then I'll have to multiply it with minus 2, correct?
Yes.
Isn't it? So I'll get minus 3I
Minus
minus
3 J
3J minus
minus 2
2K.
K.
So that will give me A cross B.
P.
Now as far as the magnitude of A cross B is concerned, it will be equal
Root
to 18 plus 4, that is 22, correct?
22.
So root
22.
22.
Yes.
So unit vector will be equal to minus 3I cap minus 3J cap minus 2K cap divided by root 22, correct?
Yes.
Hello.
Yes.
Okay, fine. So then we have done the theory of vector as far as our physics is concerned, correct?
Hmm.
Tomorrow, first to begin with, we'll do some few exercises that are related to this topic, okay? And then we'll go and do units and dimensions, okay?
Okay.
That means everything, units, dimensions, error, except instruments. Maybe if you got time, we will do instruments also. That is the vernier caliper and spring gauge, how to find least count, how to use positive error, negative error and all. Okay.
I wanted to ask you one thing. Is there anywhere I can access these notes? Have you saved it somewhere?
I'll send a video for it. It is not accessible. I have recorded this video. So I'll send a
Okay, okay.
recorded video to you.
So when I revise, I can go through everything again because I did not write everything
That's
down.
why I record it. Whenever it is finished,
Yes.
I'll send the recorded part to you. Okay.
Yeah. Because I tried to take screenshot, but then everything I couldn't take. So
You could also do that. I can give it. Some places I got PPT. Now this is so rudimentary. I have a PPT for it, but I
okay, okay.
thought there's no point in because it takes a lot of time to go through the PPT. Correct.
Yes,
Recording
yes.
stopped.
So what we can basically do is this time I'll send you when I don't have any notes, I give you especially when I do the sums, correct? When I do the
Yes.
numericals, then that is not
Yes.
in PPT. That has to be gone through recorded ones, correct?
Hmm.
Otherwise, I'll send you the PPT because it's a notes in itself. Okay. So you'll get
Yes.
the notes also.
Fine.
Okay. So either way, you'll get it. Okay.
Okay, okay.
Chalo. So today we'll finish it up, and tomorrow we'll again be doing physics because I need to continue this and finish this chapter. That
All
is
right.
vector and unit dimension and those things. Instrument
Yes.
all. So once we have done, maybe tomorrow, maybe day after tomorrow, but once we have done that, then only we'll start maths. For
All right.
maths, you can just go through the formulas of trigonometry and the value
Okay.
table, like how to compute 240 sine of 320 and all these things.
Yes, yes.
Because that will be helpful when we do calculus, because that's what we're going to
We
do.
are not doing trigono functions, right? We're just doing identities,
No.
right?
Just remember the IDTs because if you don't know even that, I can teach you. But if you know it, you just need to remember the identity. You don't need to know the
Okay.
proof of the identities. You just
Okay,
need
okay.
to, you have a table. If you want, I'll send you the formula table. Just
Mm-hmm.
keep that with you and remember, because then when we do trigonometric functions, we'll do that time. I'll elaborately tell you what trigonometric functions are, because there are graphical ways, then there is
Yes,
inverse, then
yes.
there's a lot of things to do. Correct, but that
Yes.
will be a part of calculus. But when you do that,
Hmm.
identities you need to remember. Okay, that is
All
either
right.
I will send you the formulas, the identities for you. Okay,
Okay, okay.
so you can keep a record of it, and this I'll send you the recorded video.
Recording.
Okay,
Yes, yes.
chalo then. Okay,
Yes.
bye.
Thank you so much,
Bye.
sir.
Bye. Bye.
Bye,
Bye.
bye, bye.